I am R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we are going to see the topic reflection factor and reflection loss for the course transmission lines and antennas. So, what will we say if the received signal at the load side is not same as the original signal at the transmitting side? We know that the losses occurred in the transmission line. So there are three types of losses. One is the reflection loss, second one is return loss, and the insertion loss. So for getting reflection on a transmission line, we should take the voltage and current equation on a line in standard form. E is equal to ER into ZR plus Z0 by 2 ZR e power gamma L plus ZR minus Z0 by ZR plus Z0 e power minus gamma L. Similarly, the current equation I is equal to IR into ZR plus Z0 by 2 Z0 e power gamma L minus ZR minus Z0 by ZR plus Z0 e power minus gamma L. So in this there are two terms. One is the component varying e power gamma L and another one is the component varying e power gamma minus gamma L. So the component varying e power gamma S is the incident wave. The wave travels from the sending side to receiving side of the line. And the component with e power minus gamma S is the component which is decreasing in amplitude when it approaches to the sending end. So this is the reflected component. So the component varying with e power minus gamma S is reflected wave, that is the wave is progressing from the receiving end toward the sending end. So this what happens is decrease in amplitude from the load happens, and we have the two waves. One is the incident wave and the reflected wave is in dotted lines. So reflection coefficient, the ratio of amplitudes of the reflected and the incident voltage waves at the receiving end of the line is called as reflection coefficient, denoted by the letter K. K is reflected voltage at load by incident voltage at load, and it is given by the formula ZR minus Z0 by ZR plus Z0. And we know the voltage equation ER into ZR plus Z0 by 2 ZR e power gamma S plus e power minus gamma S. Similarly, the current equation I is equal to IR ZR plus Z0 by 2 ZR e power gamma L minus e power minus gamma L. So to find out the reflection factor and reflection loss, we have taken the voltage source E at the generator side, and input impedance is Z1 and the load impedance is Z2. So if Z1 not equal to Z2, the impedance is not matched. So the magnitude of reflection is the current actually flowing in the load under mismatched condition and to the current which would flow if the impedance were matched. So I2 by I2 dash. So here we are going to use the technique called image matching. So the matching between input and output side is matched with the use of transformer and phase shifter. Transformer is used to obtain the amplitude matching or magnitude matching, and phase shifter is used to achieve the angle matching, phase angle matching with the input and output side. So according to the theory of ideal transformer, we know I1 by I2 is equal to root of Z2 by Z1. So by under matched condition, this I1 is the total generator voltage E by 2 times of Z1, and so the I2 is E by 2 root of Z1 into Z2, and without image matching, I2 is equal to E by root of Z1 by Z2. We know the reflection factor is the ratio of I2 by I2 dash. So we have 2 root of Z1 Z2 by Z1 plus Z2, and the change in the current in the load due to reflection with the mismatched condition is called reflection factor, given by the formula K is equal to 2 root of Z1 multiplied by Z2 by Z1 plus Z2. Reflection loss in uppers is Ln of z1 plus z2 by 2 root of z1 into z2. Reflection loss in decibels, it is 20 log of z1 plus z2 by 2 root of z1 into z2. Reflection loss is defined as the number of neppers or decibels by which the current in the load under image matched conditions would exceed the current actually flowing in the load. It is reciprocal of K. So, the effects of reflection on a line: reduction in line efficiency, power loss, cause echoes, generate power and frequency will change, noise disturbance occurs. So, assessment, we know reflection factor K, it is the reciprocal of reflection loss and the reflection coefficient. Thank you.